Hope you can hear me. So yeah, I'm currently working on trying to mash up IPLD, which is the Interplanetary Linked Data System, and Wasm. Basically, IPLD is a system for, I guess it's an abstraction over Merkle trees, over Merkle-linked data. Like basically allows you to like work with multiple different types of Merkle-linked data, like Git or Ethereum or Bitcoin blocks, or even like just arbitrary tags of JSON. You can link together by a hash in a standard way. So we use this to like have standard transports that operate over where they can transfer and sync Merkle trees between multiple computers. We also use this to like write with selectors over data, where you can actually query the data with standard language. We also have languages for we also have languages for describing different data structures and the types and the types you can have there, that kind of stuff. Okay, so that's what IPLD is. The core things you need to know is that there are CIDs or content IDs, and there are codecs. The codec is the format like Git or JSON or whatever. Could you go to the next slide? That was actually what I was describing. I was bored earlier. But yeah, you have it there. Next slide, please. Yeah, so what we're trying to do here is basically mash up again IPLD and Wasm. So instead of just working over like just like links and stuff like that, which you usually in Wasm, it's the function types that you have. Instead, you operate over IPLD data. So it's actually giving you structured types. But it's cool because it actually lets you sort of like link to an entire like tree of data, which is not something that you can otherwise easily do. And basically, you take the function to take an input CID, which is a content ID, and you have an output CID, or an output DAG. If you want to have like a method or define a method, you would take in an input state and an input parameters as, again, effectively objects, and then you spit out a new state and a new output. So for example, we're planning on using this to define a virtual machine for PowerPoint, which is the hope. Yeah, we're also planning on having EPM support. Yeah, can you actually hear me? Or is it? I can
yeah, we hear, but there is some like beeping sound on the background, and it's really
let me just quickly walk down the street. I'm really sorry.
No worries. That's a digital nomad life. We know it.
Yeah, sorry. I thought this was going to be live.
Okay, show us some of the views of the city.
Okay, so hopefully it's a little bit better. Let me go keep on running. Okay, hopefully that's a bit better now. The way of construction. Okay, again, I'm really sorry about this. Yeah, so basically, yeah, like our goal is to build something, basically a VM on top of this. But our goal is also to be able to use this for like IPFS in general. So like we have this problem in IPFS where like we have to like you kind of have to bake everything into the protocol. Where instead we really have to be able to ship code to people. So our goal is to be able to basically ship Wasm modules as IPLD objects, as IPLD trees, and transfer them with content or message addressing. And then kind of define things later. That's not entirely the point of this talk, it's just one of those. Next slide, please. Yeah, so this is trying to cover like why we want to do this. Again, what I talk about here is like with IPLD data, it's all network transparent because everything is always serialized. It's a bit of a problem as well, but it means like you can have these functions and like your methods, and like kind of like at every point you always have the serialized data. You can always transfer between nodes. It's also reasonably efficient in certain cases where, for example, because like you can link to other objects, only the change data needs to be transferred. So like you can point to a very large tree of things. Same with Ethereum, you can point to like your state tree. You will need to actually like move around the changed pieces. The other cool thing is like if you have proper support in your VM, you could lazily load code. So for example, you have a module that makes another module by CID, and then it can lazily load the code on demand as necessary. Finally, yeah, you can pass around large data structures without copying. So whatever hopes here is like, I can have my smart contract can call someone else's smart contract and like pass in some sub tag of the state, have that smart contract operate on that sub tag of the state, and then return like transform DAG. The EVM kind of supports this right now, where like I can call someone with a delegate call, but then I give them full access to everything, or I can send them data and then receive the data back. But then like I have to like pay for sending everything. But in this case, I can kind of just say, look, here's a reference to all of my data. Do what you want to it. I can get it back, then I can verify that they did it correctly, and then link it back in. Yeah, it's secure because everything is content addressed by CID. Everything is also structured, unlike unstructured data like it's just arbitrary bytes. So you can actually explore the data, understand it, and there's a bunch of comment to all. That's really why. Next slide, please. The why not is inefficiencies. Everything is always serialized and always hashed. The impact of this depends on the granularity of functions. If you have like tiny little functions, it's not going to work. If you have just sort of like big things like kind of like full contracts, it works better. But this can also be optimized away in many cases. So the hope really is that we'll be able to find ways to do that. But yeah, that is really what I wanted to talk about.